Welcome to the GATE video session. I am myself V.SUREKA from S.A.E. Engineering College, Computer Science and Engineering Department. Today we are going to see the topic of computer networks. From computer networks we are going to cover data link layers today. So let's go into the topic. So first we should know these are the different layers in OSI model. So here we are going to see about the data link layer, which is the second layer here in the OSI model. What is the use of data link layer and what it does அப்படிங்கிறது தான் we are going to see over here. It is responsible for moving the data or the frames from one node to the another. Is the need of the data link layer, or it is the use of the data link layer which is responsible for that. The different services provided by the data link layer are framing, error control, flow control, physical addressing and access control. Today we are going to see about the topic of flow control. So before we go into flow control, we should know what is flow control is about. So we can have this particular representation for us to know about what is flow control. If you are going to transfer data from device A to device B, it need to transfer from this particular device to the device B through some of the medium over here, which is going to be used over here. Though to transfer the data from A to B, the control of the data, it's very much important over here. The sender and the receiver, they will not be in the same thing of communicating the different data over here. The receiver will have the things of it is in need of the things that it can only process only few things at a time, whereas the sender, it can transfer many things at a time. So the flow, it should be controlled over here from moving the node or moving the data from one particular device to the another. That's the thing we are going to see over here in this topic of flow control. So flow control is nothing but, as we were telling here, it's about the speed matching mechanism. Here the receiver, it will not be able to process everything over here what is being given by the sender. So for that particular thing, we are in need of the how the flow it can be controlled. So here we are going to see about the different protocols of flow control protocols. So these are the different flow control protocols we have. It has been classified into noiseless and noisy channel. In noiseless channel, we will be seeing about what is stop and wait. In noisy, we will be covering about the different protocols over here of stop and wait ARQ, go back and ARQ, and selective repeat ARQ. So first we can see what is stop and wait protocol. So stop and wait protocol, it's nothing but here it's a unidirectional one. The sender will be sending the messages, whereas the receiver will be receiving the messages. So here what is this does, it's nothing but the rules will be given over here. The sender, it will be sending one packet at a time, and the next packet it will be sending only after the acknowledgement from the receiver it gets the acknowledgement. What receiver it does is that receiver will consume the data packet which is given by the sender, and after the consuming the packet, the acknowledgement will be given to the sender. So this is the illustration for stop and wait protocol. Sender will be sending the packet to the receiver. The receiver, after it consuming the packet, it will process and it will give the acknowledgement. Only after it receives the acknowledgement from the receiver, the sender, it will be sending the other packets. Like this, actually the data packet will be sent to the receiver. After it gets the acknowledgement from the receiver, the sender will send the other packet. This is how the stop and wait protocol it works. Why it is stop and wait? It's nothing but it will send the packet, it will wait for the acknowledgement from the receiver, and then after receiving the acknowledgement, the sender will again send the packets, and after receiving the acknowledgement, it will send the next packet. This is how it works. So that is your stop and wait protocol. Here we have few problems to be addressed over here in your stop and wait protocol. The different problems we have over here is that first one is about problems due to loss of data. The frame, it can by itself, it can be lost. So the sender should wait for infinite amount of time. The receiver waits for the data for infinite amount of time. That's the first problem over here in the stop and wait protocol. The second problem is that the acknowledgement itself, it can be lost. Again, in that particular case, what will happen? Sender waits for an infinite amount of time for the acknowledgement to be received. The next problem here in stop and wait protocol is that delayed acknowledgement. So after the timeout on the sender side, the delayed acknowledgement might be wrongly considered over here as acknowledgement for the other data packet. So these three are the problems we have over here in your stop and wait protocol. To address these problems in stop and wait, we have the other protocol over here of, we are going for stop and wait ARQ protocol. ARQ is nothing but automatic repeat request. So what is this particular thing it will do? It's that the same consideration here, it is also unidirectional, and here we are going to include the concept of timeout, and the sequence numbers will be included over here to overcome the problems which we had over there in a stop and wait protocol. Let us see how the problems it has been overcome over here. So we have different scenarios. First one is that in the first scenario, the acknowledgement is received before the time expires. What does it mean? So the sender will be sending the frames. After the receiver it consumes the data, it will be given, the acknowledgement will be given to the sender before the time it expires. It's a normal flow of the data which is happening over here. The second scenario, what is happening over here is that it's nothing but the frame itself, it can be lost. So at this case, what it can happen, the sender will wait for the timeout. Till the timeout, it will be waiting for the acknowledgement. If not, what it will be doing is that it will be automatically sending the next the frame which has been already given to the receiver, and it will be waiting for till the timeout of for the acknowledgement. This time the receiver, it gives the acknowledgement before the timeout. So this is the second scenario of how if the frame is going to be lost. The third one is that if the acknowledgement is going to be lost, what it is going to happen is the case which is given over here. Sender will send the frame, and the receiver will receive the frames, and the receiver, what it does is that it will process the data, and the acknowledgement is given to the sender. But the acknowledgement, it could be lost over there in the during the transmission. So what it will be happening over here is that it will wait for the timeout again over here. After the timeout, the sender will be sending the frame again. Here we will be introducing the concept of sequence numbers, for which frame the acknowledgement is being given. So here we can also include the sequence numbers over here. The frame 0, it is being sent over here in the previous one, where the frame 0, it has been received to the receiver, whereas the acknowledgement is lost over here in the transmission. So at that particular time, what the sender will think that till the timeout it will be waiting, and then after few seconds, or according to the time what it has, it will be sending the frame again. Which frame is being given to the receiver again is the frame which has not got the acknowledgement. So if we are going to consider this as frame 0, again the frame 0 will be sent over here, and the receiver, what it does is that the receiver will have the frame 0, already the frame 0 will be there in the receiver side. So what it will be doing is that receiver will discard the frame, and it will be sending the acknowledgement for the frame 0 what it has got already. So that's how if the acknowledgement is lost, this is how it works. So the next scenario what we have over here is the timeout fires too soon. So what is this particular scenario is that the frame will be given to the receiver by the sender. The acknowledgement will be received by the sender after the timeout. It can be of the things that during the particular transmission, some network failures or something could have happened. So the acknowledgement, it is being received after the timeout. So before the timeout, it can fires out soon. So that's the scenario of the timeout fires too soon is the scenario which is given over here. So these are the different things what the problems we had in stop and wait protocol is being overcome over here in the stop and wait ARQ by using the concept of automatic repeat request. After the timeout and using the sequence numbers, we will be solving the problem of what we had in our stop and wait protocol. The next one what we are going to see over here is that noisy channels. So in noisy channels, the other two protocols we have is go back N ARQ, and the second one is selective repeat ARQ. Before we go into these two protocols, we should know what is sliding window protocol. So to go into this topic of go back N ARQ and selective repeat, first we can see what is sliding window protocol. So what is the drawback we had over there in stop and wait ARQ is that only one frame is being given to the receiver at a time. So that what it happens, the bandwidth is being utilized bandwidth is used very less over there, so that it can lead to the poor performance over there. To overcome that concept of things, we are going to the protocol of sliding window protocol over here. At a time, multiple frames can be transmitted over here, and how the multiple frames it can be transferred is that it is based upon the window size. Based upon the window size, how much frames it can be given to the receiver at a particular time is the sliding window protocol. It will be used, and here also we will be going for the sequence number concept, and the timer is also used over here. So this is how the sliding window protocol it works. So here the sender wants to send 10 frames or 11 frames or 12 frames. How much frames it can be? It is being deciding. The deciding authority is based upon the sender how much frames it is going to be sent. So based upon the window size, it's very important to know over here about the window size. Based upon this window size, we are going to send the frame how much frames it can be given to the receiver from the sender. That's the concept. It's very important about knowing what is window size. At the particular time, before getting the acknowledgement from the receiver, how many frames it can be given from the sender to the receiver. So here the window size is given as 4. So before receiving the acknowledgement from the receiver, how many frames it can be given to the receiver is that we can send 4 frames at a time. So before this particular sliding window, we were discussing about stop and wait for ARQ. In that particular protocol, we will be sending only 1 frame, which the bandwidth utilization would be very less over there. To improve that particular thing, we are going for a sliding window protocol. Here we will be sending, based upon the window size, we will be sending multiple frames at a time. So we can send 4 frames at a time. That's the window size which has been given over here. So the sender will be sending the 4 frames 0, 1, 2 and 3. 4 frames will be given to the receiver. The sliding window, what it will be doing is that how much frames it has been given to the receiver, it will be showed over here in the sliding window. That's 4 frames it is being given to the receiver now. So now what is happening over here? After receiving the acknowledgement of 0 from the after receiving the acknowledgement for the frame 0, what the sender it will do, it can send the next frame. Why? Because the window size it is 4 over here. After receiving the acknowledgement from the receiver for the frame 0, there will be only 3 frames over here. So we can now send a particular frame to the receiver since the window size is 4. So we are sending the next frame of 4 over here, and the sliding window will be moved from 0, 1, 2, 3. Now it will be moved to 1, 2, 3, 4 since we are having 4 frames to the receiver. Now what it does, again we are receiving the acknowledgement for the frame 1. After receiving the acknowledgement for the frame 1, what is happening over here? The sliding window, it will be moving to the next one of sending the frame 5 to the receiver. That's what which is happening over here. So this is how the sliding window protocol it works. Once the acknowledgement is being received to the sender, based upon the window size, the sender can send the frames how much it can be possible for the current window to be given over here. So window size, since the window size is 4, after receiving the acknowledgement for the number of frames, we will be sending the next packet over here. So what is this particular thing it represents is that these are the frames which has received the acknowledgement from the receiver. We have received the acknowledgement for the frame 0, 1 and 2. We have received the acknowledgement. So what is this 3, 4, 5, 6 in the sliding window it is been indicating over here is that we are waiting for these frames to be acknowledgement from the receiver. So these frames are the frames which has not yet been given to the receiver. This is how the sliding window it works. Based upon this concept, we are going to see what is go back N ARQ, which comes under the concept of sliding window protocol. That's the thing we are going to see over here. So what is go back N ARQ? The name itself, what it is telling over here, go back N ARQ. N here, what does it represent? It means that suppose during the transmission, if any of the packets which has been, it can also be the frame, it can be lost, or it can also be the acknowledgement in the middle of the transmission, it can be lost. So at that particular time, what we are going to do, we are going to send the frames after the timeout. We are going to send the frames which has been lost from that particular frame. We are going to resend all the different frames which is given over here. That is your go back N ARQ. So all the frames in the current window are transmitted again if the acknowledgement of the frame is not received within the agreed time period. That is the go back N ARQ. So now let's see, it's based upon the window size. Here also it will be based upon the window size, since it is working under the concept of sliding window protocol. We'll be having the sequence numbers for each frames, because the sequence number here are very important, because from the sender how many packets it's going, and the receiver side after processing it is be acknowledgement, giving the acknowledgement to the sender for the frame which is being processed. So that's why the sequence number and the timer are very important over here. So now let's see how the go back N ARQ it is working over here. Here the window size is given as 4, and what is it represents actually? Since the window size is 4, the sender it is sending the first 4 frames to the receiver. After the receiver it processes the frames, it is giving the acknowledgement to the frame 0 and frame 1. After frame 0 and frame 1, it is given the acknowledgement to the sender. So how many frames will be there in the sender side now? Only 2 frames it will be there. So what is being we can understand from here is that we can also send other 2 frames now. So the sliding window it moves from 0, 1, 2, 3 to now it is being moved to 2, 3, 4, 5. So now it is ready for us to send the other 2 packets over from sender to the receiver. So 4th packet and the 5th frame it is given to the receiver. So it is again waiting for the acknowledgement from the receiver side for the packet 2. But here what is happening is given in the illustration, the acknowledgement from the receiver for the frame 2, it is being lost in the middle. After the timeout, what will happen is that what is happening over here is that since the packet of acknowledgement for the packet 2 is lost, the concept of go back in ARQ it's nothing but it will be waiting for certain time. After the timeout, it will be retransmitting the frames in the current window, that is 2, 3, 4, 5. For the packet which is not been received acknowledgement from the particular packet, we are going to retransmit all the frames based upon the window size. That is what which is happening over here. Since see over here, already the 4th frame and the 5th frame it is being given to the receiver. Since the acknowledgement for the packet 2 is being lost in the middle of the transmission, so what we are going to do, we are going to discard the frames of 4 and 5 which is already been given to the receiver, and now we are going to retransmit the frames what is there in the current window, that is 2, 3, 4 and 5 will be retransmitted again. These frames of 4 and 5 which is already been given to the receiver will be discarded by the receiver, and the retransmitted frame will be now given to the receiver. Now this is how the go back in ARQ it works. From which packet the acknowledgement is being lost, from the particular packet we are going to retransmit the frames to the receiver. This is our go back in ARQ. So based upon the concept of go back N ARQ and the few protocols what we have discussed till now, we are going to see the question how gate question of how the problem it is going to be based upon these problems, what are these concepts what we have discussed now. So what is the question which is given over here? Station A needs to send a message consisting of 9 packets to station B using a sliding window. Here we are using the concept of sliding window protocol. It can be of selective repeat or it can also be of a go back N ARQ. We can see now what is being given in the question. So the window size what they have given is 3 and go back N error control strategy is used. So they are given in the question that the protocol what they are going to or we are going to solve using is that we are going to use go back N ARQ is the one we are going to use over here. From station A to the station B, how many packets it's been transmitted over here? 9 packets it's been transmitted and the window size what is that they have given is 3. We should read the question carefully. Next, all the packets are ready and immediately available for the transmission now. If every 5th packet that A transmits gets lost, A is transmitting each and every packet, every 5th packet what the sender is been sending is being lost is given in the question. But also we should know that but no acknowledgement from B ever gets lost. Only the package from sender to the receiver is being lost, and they have given in the question that the acknowledgement for none of the packets are getting lost, which is being given by the station B. Then what is the number of packets that A will transmit for sending the messages to B? So here what is the question they have asked? So number of packets that A will transmit for sending the message to B. How many packets it will be sending from A to the station B? That's the answer we are going to find out here. It can be of 12 packets or it can be of 14 or 16 or 18. That's the thing we are going to compute over here. Okay. So what is given in the question, we should understand the question first. 9 packets are given from station A to station B. So we will be having 9 packets over here. What is the window size? It's being mentioned in the question. It is 3. So based upon the window size, the packets will be transferred from sender to the receiver. Since the window size is 3, we are transmitting 3 packets now. So what we are going to do next, after receiving the acknowledgement for the packet 1, now the sliding window it moves to from 1 to 3 to 2 3 4 it will be moving. Now we are going to send the 4th packet since we have got the acknowledgement for the first packet. Since the window size is 3, we can have 3 packets in the current window. So now the acknowledgement for 1 it is being received. So what is happening next? Acknowledgement for 2 is also received. So what we can do now? We can move the packet of next packet from sender to the receiver. So we are moving the 5th packet from sender to the receiver now. Again, what is happening over here? We will be getting the acknowledgement for the 3rd packet. After getting the acknowledgement for the 3rd packet, what we will be doing based upon the protocol's rules? We will be sending the next packet which is there in the current window. We will be sending the packet to the receiver side. So we have got the acknowledgement for 1, 2 and 3. Since we are sending the next packets 4, 5 and 6 again. So now we are getting the acknowledgement for the 4th packet. After we get the acknowledgement for the 4th packet, what is happening over here? We are going to send the 7th packet to the receiver. Now what we are going to do? We are going to wait for the acknowledgement for the 5th packet. Since for the 4 packets we have got the acknowledgement. Now we are waiting for the next 5th packet to receive the acknowledgement. But what is given in the question? Every 5th packet which is sent by the sender will be lost. So this 5th packet which is sent by the sender is lost now. So what is that? It will going to happen. It will wait for the timer over here. After few minutes or few seconds over there for the timeout, what is happening? What will be happening based upon the protocol or based upon the rule over here? After the timeout, which packet is lost, from the particular packet we are going to resend all the packets again. That's the protocol of go back N ARQ. Here the N is nothing but the fifth packet. Since the fifth packet is lost over here, we will be resending all the packets from 5. So we are resending the packets of 5, 6 and 7 now. Okay. So we are sending the packets, resending the packets of 5, 6 and 7 now. These packets which is already given to the receiver, 5, 6 and 7 will be discarded by the receiver, and we are sending the packets again of 5, 6 and 7. Now it is being retransmitted again. Once it is being retransmitted, what is happening now? Now we are getting the acknowledgement for fifth packet. It is not that the sender, when it sends from the sender side, every fifth packet is lost, whereas here 1, 2, 3, 4, 5, this fifth packet is lost, which is being given by the sender. That's why we are doing the retransmission of the other 3 packets what was there in the current window. Now the packet, this is not the fifth packet actually. 1, 2, 3, 4, 5, 6, 7. This is our 8th packet. So we are receiving the acknowledgement for this packet of 5. Once we have received the acknowledgement for packet 5, what we are going to do next? We are going to transfer the 8th packet from sender to the receiver. So what is happening next? It will be, we are getting the acknowledgement for the 6th packet too now. After receiving the acknowledgement for 6th packet, based upon the window size, what we are going to do? We are going to send the 9th packet to the receiver. Again the 9th packet will be given to the receiver. Now what is being actually, we should again see. We are waiting again for the acknowledgement for the 7th packet. Now it will be, the sender will be waiting for few seconds based upon the timeout. Now what is happening again? See the number of packets which is given by the sender. Every fifth packet is being lost is given in the question. So 1, 2, 3, 4, 5. This packet is being lost. So again the packets 5, 6, 7 was retransmitted. So this was 6, 7, 8, 9 and this is our 10th packet. Every fifth packet is being lost. So this is the 10th packet. So this packet is being lost over, which is given by the sender again. So now what will happen now? After the timeout, the sender will again retransmit the frames which is there in the current window. So that's what which is given over here again. So this 7th packet is our 10th packet from the receiver side. So this is being lost over here. So we are again retransmitting the frames which was there in the current window. That is, we are transmitting 7th, 8th and 9th packet over here. So these packets which are already given by the sender, 7, 8, 9 will be discarded and the packets is being retransmitted over here of, since this is our 10th packet. So after retransmitting, what is happening over here? The 7th packet is being acknowledged from the receiver. Again 8th packet is being acknowledged by the receiver. And do we have any other packets to send from our sender side? No, we don't have. So how this works again? See, all the different frames which is given by the sender, packets is being given by the sender, is being received by the receiver. Every fifth packet is being lost. Based upon that, we did few retransmissions over here, and now we are waiting for the 9th packet to be acknowledged from the receiver. Whereas what is this 9th packet from the sender side? Again see, 1, 2, 3, 4, 5th packet is being lost. We have transmitted again. Now 6, 7, 8, 9 and 10. Again this is our 5th packet in the sequence of the sender. So this packet was lost. We are sending the retransmitting the frames of 7, 8, 9, 10. So 11, 12, 13, 14 and 15. This is our, again from the sender side, this is our 5th fifth packet again. So every fifth packet is lost from the sender is given in the question. So again this packet will also be lost, which is from the sender side. So after it will be waiting for the sender will be waiting for timeout. After the timeout, it will be sending the frame which is there in the current window. Here, since there is only one packet in the current window to be retransmitted, we are transmitting the 9th packet now. After retransmitting the 9th packet, this is not the 5th packet in the sequence of the sender. So now we are getting the acknowledgement from the receiver side. For the 9th packet also we have received the acknowledgement. So the frames which is being given from the sender from 1st packet to the 9th packet is given to the receiver now, and for all the 9 packets we are getting the acknowledgement from the receiver side. So what was the question which is being asked? What was the question? What is the number of packets that A will transmit for sending the message to B? So how many packets we have transmitted from sender side till now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. From sender side we have transmitted 16 packets to the receiver. So the number of packets transmitted by A is 16. So that's the answer for our question of which is being asked over here. So this is how we are going to calculate if we are going to get the question from our protocols in our flow control. Okay, here we have used go back NARQ to calculate how many number of packets have been transmitted to the receiver based upon the condition. What is the condition they have given? Every 5th packet which is being lost, and how it will be retransmitted based upon the protocol of go back N. We have given the explanation of the discussion we had now. After the discussion we can come to the conclusion that 16 packets have been given from the sender A to the receiver. So answer for our question is 16. So the number of packets transmitted by A is 16. Okay, hope everyone understood the concept which is being discussed over here. Hope thank you, and we can see in the next another session of our gate class. Thank you.